So far I talked about segmentation by thresholding, and we saw that the methods in this approach have a big trouble when the histogram does not have clear values. Okay, if we face a lot of troubles in that, it is recommended to go and test another approach, for example, region-based segmentation, which does not depend upon the value in the histogram, and just we go and detect the region in a direct way. So this is what I'm going to discuss in this video, which is a new approach that is called region-based segmentation. Region-based segmentation, and there are two main techniques, but before discussing them we have to set some rules for which we consider that a region-based segmentation is correct. Okay, so let's say that I have an image that has for example 4 segments. Okay, this is segment 1, 2, 3 and 4. So the first rule is that the first rule is that the union of all of these regions Ri, such that I is equal 1 to n, should be equal to R. So what is this? So R is the region represented by this entire image. Okay, so R is just the image. R is just the image, and Ri is a given segment. So this is R1, R2, R3, and R4. So in this case, I equal 1 to 4. Okay, so the union of all of these regions must lead to must yield the region of the image. Okay, the second rule is that two regions that are different, the intersection of two regions that are different must be equal, must be none. Okay, must be empty. For example, the intersection of this region and this region is empty. There is no intersection. Otherwise, the segmentation is wrong, is not correct. We should not have overlapping regions. Okay, so in the third is that a given region must satisfy a similarity property. For example, a region Ri must satisfy a similarity property, and this is represented by P for predicate. Okay, the predicate of a given region must be true, and this predicate here, predicate, is nothing but a similarity criteria. Okay, similarity criteria or criterion. Oops, I run out of ink. Have to change this pen. So I said that this predicate is a similarity criterion. Okay, so each region must satisfy that similarity criterion, which can be related with the property of a region. It can be, for example, a color. It can be intensity level. It can be something like texture. So these are regional descriptors, okay, and they are used in segmentation, and they are also used for other purposes. This is an independent topic that there are independent topics that deal with regional properties. Okay. And there is regional properties, and there is also properties related with the contour, with the boundary, not only with the region. So we can also use that as a criterion, right? And the fourth rule is that the union of two regions that are different, they should not have the same similarity criterion. Okay, so this region, for example, here 1 and 2 their union should not satisfy the predicate that we defined for the segmentation. And if they do, normally what we should do is just to consider them as one region, okay, one segment. So mathematically we should write that as the predicate of the union of these two regions it must be equal to false. So these are the four main rules that we have to bear in mind while doing the segmentation. So there are two segmentation techniques in this type of approach, region-based. There is region growing and regions merging and splitting. And this is what I'm going to discuss in the next videos.